Hello, welcome to a video on thermal energy. This is beginning our heat and temperature section. To be completely honest, I'm not really sure what's going on with this image, but it came up when I typed thermal energy into Google, so it's obviously a lot better than whatever I was looking for. Thermal energy is made up of the combined potential energy and the kinetic energy that is due to the vibration of the particles within an object. The particles within an object with higher temperatures have a higher average kinetic energy, and an increase in the temperature of an object is due to an increase in its thermal energy. In Stage 2 physics, you'll need to describe the links between temperature, vibrating particles, and thermal energy. So first we'll take a look at the kinetic particle model or kinetic theory. As we probably know, all matter is made up of atoms, ions, and or molecules, and these particles are in constant motion if they're not at 0 Kelvin. I'm not sure if you would have already looked at different scales of temperature, but we will look at this I think in the next video. If you're not sure what 0 Kelvin is now, you will be, but it's basically the lowest possible temperature that anything can get to. So if an object or if particles aren't at 0 Kelvin degrees, which is like minus 273 degrees, then they'll have some form of motion, and the type of motion depends on the particle's freedom within a material. So that will vary depending on whether a particle is making up a solid, if it's making up a liquid, if it's making up a gas. There'll be different degrees of movement within those, as you might imagine. The three types of motion that we'll look at are translational, and that is talking about when a particle moves in a straight line from its original position. There's rotational motion, so the particle rotates around an axis. It doesn't necessarily have to be in the centre like in this diagram, but it's rotating around an axis somewhere along its body. And then there's vibrational, so that's when a particle oscillates about a fixed position, and there's a few different types of vibrational motion, like it could be symmetric, asymmetric, but it's when the particle is oscillating. So as I mentioned before, the type of material will dictate generally the type of motion particles within that material will have. So for solid materials, particles have vibrational motion as they're tightly packed, and this is because there's strong electrical forces of attraction between the particles of a solid, so they want to be close together. Because of this, particles are restricted to oscillating about a fixed position, so even though they're tightly packed, there's still enough room to move slightly, so to vibrate, but you won't get any rotational or translational motion. In liquids, particles have vibrational, rotational, and translational motion, and this is because the electrical forces of attraction are weak, so there's more freedom for the particles to move around in those different ways. With gases, particles have, again, vibrational, rotational, and translational motion, and translational motion is the most common type of motion in gases. This is because the electrical forces of attraction are very weak in gases, so particles are whizzing around all they like. Particularly they're whizzing around with translational motion from moving from one place to the next, because there just is so much freedom in a gas. So moving on to thermal energy, and this is the sum of potential and kinetic energies of particles in an object. This potential energy is referring to the electrical, attractive or repulsive forces between atoms, as well as the nuclear forces between protons and neutrons. So not the gravitational potential energy that we've gotten a bit used to over the last, few months. It's a different type of potential energy. And kinetic energy, as we're hopefully familiar with, is the energy due to motion of particles. as we were discussing the type of motion you can have before, we can have translational motion, rotational motion, and vibrational motion. You can therefore have translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. So just to reiterate, thermal energy is equal to the potential energy of the particles of an object plus the kinetic energy of the particles in an object. Temperature is the measure of the average kinetic energy of particles in a material or an object. At higher temperatures, particles have more kinetic energy, and they therefore have greater thermal energy because thermal energy is equal to potential plus kinetic energy. So if you're increasing the kinetic energy, then you're obviously going to have a higher thermal energy. So for example, we've got a gas here. There's the same volume, so I've got eight gas, particles in each of these environments, but one is at a low temperature and one is at a higher temperature. At the lower temperature, the particles will be moving around a bit more slowly, so they'll have a lower velocity and therefore a lower kinetic energy. Whereas at a higher temperature, they'll have a higher velocity, there'll be more movement, and therefore their kinetic energy will be greater. So the more kinetic energy particles have, the higher the temperature of the material or the object.